This is the third and final part of the MSP Introduction. So you should have watched the first two videos already. If you haven't, then please go and watch them first in order for this tutorial to make sense. So in the previous tutorials we've established the difference between MSP and Max objects. We've looked at the visual differences in terms of their appearance, but also we've talked a little bit about how they work differently and the types of data and signal that they send. So in the previous patch we built a basic kind of audio in and out. We took the audio in through ADC object. We inserted a gain control and then we metered the level of the signal, and we also visualized the waveform, and then we sent the audio out of the system. So hopefully you managed to follow that and managed to build that patch. And once you built it, hopefully you can kind of understand the component parts. If you are at that stage, then please continue watching because now we're going to have a look at some synthesis objects. So we're going to introduce the fundamentals of synthesis within Max MSP. So in the previous patch we brought audio into the system using the ADC object. Obviously this is reliant on using an external audio source as the kind of audio generation part of your patch. So how we're going to kind of change this really here is by swapping this out for a cycle object, and what the cycle object will do is it will generate audio from within the patch. So we're not using audio from outside the patch, we are starting the audio generation phase from within our Max MSP patch. So you can look at the cycle help file to learn and read a little bit more about it, but essentially the cycle object will generate a sine wave, a sine waveform. So it's a sine wave oscillator, essentially, as it says here, a sinusoidal oscillator. It's actually termed cycle because what it's actually doing is it's cycling through a series of values which together make up that sine wave. In one of the tutorials it actually talks about how you can use cycle as to create like a wavetable synthesizer, so you can essentially replace the sample values that the cycle object is referencing. Don't worry about this too much for now, but it's something we will come back to and have a look at. So for now, just try to take on board that the cycle object will cycle through a series of values every single, many times every second, and this will generate a sine waveform off the back of it. So when we think about how an oscillator works, one of the key bits of information that it needs to know how to work is we need to give it a frequency value. So the cycle object doesn't know how fast it needs to move through the samples that it's got. So we need to tell it via the frequency value how fast to do that. And if you cast your minds back, you should remember that frequency is essentially establishing how many times in a second we are moving through the waveform that is saved within cycle, or that is referenced by cycle. And obviously in musical terms, the frequency defines the pitch. So obviously a higher frequency will result in a higher pitch, which to us, sounds to us as a higher musical note in a kind of psychoacoustic kind of context. So frequency will obviously relate to pitch, and pitch to us as musicians is a more useful term to use in a kind of musical and psychoacoustic kind of frame of reference. So you may now be wondering, how do we tell cycle what frequency to use? Well, one thing that we can do is we can give it an argument, and I would ask you to remember how the metronome object works, which is one that we've looked at and used quite extensively up to this point. So if you remember the metronome object, we're telling it to tick over at a certain rate. So if we turn that on, it's going to go at every 500 milliseconds, which is twice a second, and then we can...
I'm going down, we need to get going.
So we can set the metronome going, and at 500 milliseconds it will be banging out here twice every second. However, we can also override that, so we don't have to just kind of use that initial value, so we can override it by updating the value in the second inlet of the metronome. So we can think of cycle in a similar way, where we can give it an initial default value, but then we might also want to use another variable value as we interact with our patch. And obviously, in terms of frequency and pitch, we don't want to just use one frequency or one note. We want to use lots of different notes to create our complex musical sequences and so on. So as with the metronome, we can connect a number object to override that value of 1,000, what I've put in as 1,000. Incidentally though, this goes into the first inlet and not the second inlet. Don't worry about the second inlet for now. The first inlet is the one that sets the frequency, as you can see when you hover over it. So we can set this up here. So now we have created an oscillator which will also respond to a frequency value that we give it. To kind of visualize this, we can reintroduce our scope. If I can just resize this so we can see it. Like so. So we should now be able to see our waveform. So in order to start audio, remember we need to go to audio status and we need to turn our audio on. And you can see as soon as I do that, then we can see this waveform being generated. At the moment it doesn't look too much like a sinusoidal waveform. This is more to do with the view settings of the scope object. So if I just take this down to 128 and change the buffer size so I've changed those settings, and now let me just adjust the gain settings because it looks to me like it's peaking a bit too much. So we're just going to send that audio through the gain settings, through a gain control as we looked at before. And now when we bring it up, we can see it looks a bit more like a sine wave. Okay, so having adjusted some of the inspector settings for the scope, we can now visualize our waveform. And there we go, you can see there quite clearly it's a sine wave, and as we increase the gain level you can see this grows in amplitude. So you should remember the height of the waveform relates to the amplitude, and you can see here, or you can kind of visualize approximately the wavelength of each of the cycles. So as we increase this, the wavelength should decrease. Remember the inverse relationship between frequency and wavelength. And so this will continue as we go up to higher and higher frequencies. Again, it stops kind of looking like a sine wave when you get past a certain value. So that's our sine wave generator. So we've essentially got the oscillator module within a modular synthesizer created here, or a very basic rudimentary version of. So the last stage of this is to send the audio back out of the system, and again here we're going to use DAC. Remember to take the digital signal and convert it into analog to send out the system. However, at this point I'm going to introduce you to what's called an easy DAC. You've got to pronounce this in the American way, which is exactly the same object as a DAC, but it also gives you a user interface, which is actually quite handy. So here, essentially, you've got a button to turn the audio on and off. So you can see here when I click, it stops the audio freezes, which is telling you basically the audio has been turned off, and when I turn it on, it resumes. So this is quite a handy object because you've got that functionality in there as well. Before we do this anymore, I'm just going to take the volume right down because we risk getting a lot of feedback, because obviously I'm using the internal microphone to record this tutorial, so you will hear what comes out of the audio out of my computer speakers. So let's turn them on, and I'll try and push this up. Clearly at 87 Hertz you're not going to hear that very well either. So hopefully now you can start to perceive the tone. And there you can hear, as I push the frequency up, we can both see and hear that pitch going up and down. Like so. So you should be able to put this together and have a play about with it. Just be careful not to deafen yourselves. So make sure you put the gain control in. And congratulations, you have officially built your first synthesizer, because we are generating audio, we are synthesizing audio, we are manipulating, controlling it, and we are playing this audio out. So technically this is your first steps towards a greater understanding of synthesis within Max MSP.